Just moving on to this afternoon's session, I'm excited to welcome James Taylor. James is an AI engineer at Detective, and he's got a background in software engineering, linguistics, and speech technology. James has worked across forensic handwriting analysis and natural language processing. And at Detective, he uses language models to make data more discoverable and useful for clients such as the Scottish Government. In the session today, we're going to explore the rapid evolution from language models to deep agents and how AI systems have progressed from basic text prediction to structured autonomous reasoning. And by the end of the session today, you should have a better understanding of what a deep agent is, how they work, and how they differ from traditional LLMs. James is also going to cover the upskilling path. So if this is something that you're new to, we'll cover what to learn, what tools to explore, and how to start building with agentic patterns today. So that's enough for me. I'll pass you over to James now. If you have got any questions, put them in the Q&A and we'll get to those at the end. Thanks very much.
Yeah, thank you. Let me share my screen.
That's coming through now.
Yeah, good. Okay. Yeah, hi everyone. Thanks for joining. Yeah, so this is Deep Agents Demystified, turning LLMs into multi-step problem solvers. And I would say this won't be super technical, but it'll be more like conceptual and maybe architectural about how these agents that sort of every company is promising will solve every problem actually work. So we'll start with a short outline, and I will quickly introduce myself, and then we'll go over a timeline and sort of how we've built up to deep agents. And also sort of, if you're not really sure what an agent or a deep agent is, that is okay because we will cover the background info and we'll all be there together. We'll discuss sort of what makes an agent deep as opposed to other agents and the principles and components, and then sort of cement what we've learned with an example. And then we'll talk about what is current and next in agentic AI and sort of the real tools and upskilling paths, and then finish with the Q&A. And also, I've put page numbers on here. So if you have a question, it would be helpful if you have a page number with that question so that I can, after the presentation, get back to that slide quickly. Yeah. So quick introductions. Myself, I'm James. I'm an AI engineer at Detective. I did my master's in speech and language processing at Edinburgh and my undergrad in software engineering and linguistics. And most of what I do is explore how LLMs can find, clean up, and analyze data and data sets. So whether that's like pre-agentic chatbots, built one of those, agents, things like AI search overview like Google has, all of that sort of thing. And Detective, yeah, it's a small company with a few of us here in Edinburgh, and we're working to make data sets more discoverable and turning that discovery into like insight and decisions even, and working a lot with open data throughout Scotland, but also expanding. And you can see that on detective.com. So just as an example, one thing that I've sort of fully productionized and spearheaded is metadata generation. So in the case, like you have a huge data estate, like the Scottish Government, and very little structured metadata, you sort of expedite the process of getting more metadata by generating metadata directly from the data itself. And yeah, so that's all about me. And now we can go to the interesting things. So we'll sort of start with a timeline. And I've sort of split going from language models up to deep agents into 4 parts, and we'll sort of flip the cards over as we go. So the first one is language models, which I'm saying pre-2018. It is up for debate, I'll admit. I'm also grouping natural language processing models and tools into here, and just sort of grouping everything that is a stochastic system that models language statistically. That is to say, like there's some training data, and you have a probabilistic model based on that training data, and it's mostly used for like language understanding and analysis and very simple text generation, but nothing like an LLM where it can follow instructions or reason. So they're all sort of based on these word embeddings, which have like a meaning representation, and all of these words will appear in a large dimensional space with a a vector, and then you can do all sorts of things. So we'll see what we can do. Throughout this presentation, I have gone ahead with admittedly a little bit boring, but I think a practical example of an email inbox, because these tools are very often added to email boxes early, and it is something I think everyone would like to automate more is the handling of emails. And so at this time, we saw things like spam detection, topic classification, urgency classification. That's in the analysis part. And on the generation part, things like autocomplete, so like maybe one word, or template filling and spell checking. Those are kind of text generation. But a good example to cement this for the spam detection and text analysis, if you have a spam detection model trained and it has seen lots of spam emails with like free and offer and win, but maybe it's never seen like the word promotion. The word promotion will appear similar in the word embeddings to free and offer and win, and so maybe this can give a clue to our spam detection model that this one is also a potential spam email. And so we can sum up by saying that language models treat language as a series of patterns that can be modeled and represented. And we'll flip the card over, language understanding and representation. Now we can say that the next sort of big part is large language models, which is like 2018, 2019. That's when like the first of like GPT 1 and 2 sort of came out. You can argue how large those are, but we'll just say that for now. And large language models are general purpose instruction following language models that can reason over large contexts. So large context meaning if the autocomplete can look at 5 words and pick a 6th word, large language models can look at 100,000 words and pick the next 100 words, essentially. It's like much larger context and therefore much more useful, and they can generate coherent responses. And that is essentially large language models are very sophisticated next word predictors. So just a simple example, if you have my cat is, and then you've seen these in training data, they have a percentage of like how common they occur, then an LLM with the most like basic settings will always just pick the most popular one. We can make an LLM sort of more various and creative by turning up a parameter called the temperature, and that makes it pick more interesting things, pick less likely things. So like maybe a slightly higher temperatures, my cat is sleeping. Maybe a really high temperature, you end up things like my cat is having a meeting or something like that, like something that doesn't make any sense. And that's one reason LLMs can seem to just go off the rails and make stuff up. In our inbox, LLMs now allow us to sort of interpret intent and context, extract structured data. Like if there's a task, maybe the LLM can see the task and be like, should I add this task to your list? And it can just answer questions about things in the email. And then synthesis is also, this is sort of where it shines, is producing summaries, generating responses, rewriting. I've seen that quite a bit in Gmail, constantly asking if I want to rewrite for some style or tone, and translation. So we could say large language models understand or seemingly understand and generate language over large contexts. And we can flip this card over and say that large language models understand and generate over large context, and these chat versions like Chat GPT are aligned to follow instructions from humans. In the more recent years, we've started to hear about agents and agentic LLMs. And these are simply LLMs with tools, and those are combined in short reasoning loops to complete simple tasks. So it was sort of formalized in this paper, React, Synergizing Reasoning and Acting in Language Models. And that basically says that this is the setup. There's human asks something of an LLM. The LLM reasons about what it should do, like what tool it should call. It'll call the tool, see what the output is, and then reason if it needs to call the tool again, call a different tool, or if it's done the job. And it's essentially as simple as that. So now we can sort of split the things happening in our backs into two. There's the reasoning. So we could already do this. This is just LLM based. So interpreting intent, deciding if an action is required, prioritizing responses. So these are all LLM based. And then we can also have the ability to act, which is like sending replies, creating tasks, scheduling meetings, fetching support documents, etc. And we can summarize this by saying agentic LLMs make decisions and act, not just respond. To sort of cement this, we will look at a worked example using this. So let's say you have your email inbox open and you have your little, I don't know, maybe it's an assistant on the side, and you say, reply to this email. So the LLM will first reason that it needs to read the email to be able to reply to it. And then let's say there's this tool, email.read. It reads the email. It says, hey, could you find some meeting times for the entire project team next week? We need to sync up soon. So that's the email. And then the LLM reasons about what the email is asking and what it should do next. So it thinks that it should use the calendar tool to find open spots. Let's just say this tool exists, calendar.availability team. And it sees that the entire team is available on Tuesday and Thursday for 1 hour each. And it reasons again, I should draft and send a reply with this information. So maybe it goes around one more time, and eventually it decides it's done and it stops. So I hope that little example was helpful in how it combines LLMs and tools. And we can say that agentic LLMs are LLMs equipped with tools to act or interact in the world. And the world mostly means the computer. There is one main problem with sort of letting agentic LLMs do more and more complex tasks, and that is to do with context windows. So it's the context window is that black arrow here, and that is basically how many words or tokens an LLM can see. So, I mean, now they're up to, 100,000 sort of the bottom up to much more in these huge LLMs. But basically, you fill it up. So let's say this is 1,000. You have, 100 words in your first prompt. The LLM responds with some lengthy thing, and there's maybe a third of the conversational memory remaining. Once you've asked a second thing, you're sort of pushing your first prompt out of the context window. So there is some tricks with like caching, trying to save only the most important things, but you can't completely get around the fact that the LLM can only see so many words at one time, or so many tokens at one time. And so in terms of long running tasks and things that are more difficult to do, they take a lot of tokens. And so this becomes a problem. And so we can sort of see 3 failure cases. And while it's a user, it won't be obvious why it's failing. It almost is always to do with the context window just being too small. So maybe the task is just too complex. So if you ask the agentic LLM to do all these things independently, it could, but together it becomes too much to manage. So if you asked it to reply to an email, draft 5 different emails for different threads, summarize the action items, and schedule a meeting, then it's very likely to miss an action. I think it's even more likely to do something, forgotten that it has done it, and then keep going and do it again. Sometimes the context window is just literally too small. So if you ask an agent to summarize, let's say a whole email thread with documents included, it can't fit all of that text into the context window at once, and it's very likely to forget things that happened at the beginning of the thread. And sometimes the scope is just too large and there's too many tools and responsibilities. So again, if we asked it to do all these things like fetch documents, check calendars, create tasks. Um, the agent is very likely to do much poorer on some tasks than others, just because it's unoptimized for to do all of these things, and it would be better to sort of split it up. So that's where we have this notion of deep agents, in that they're more complex, they can do more complex things, and they sort of aren't shallow and simple. Um, so we can say these sort of started 2024-ish, and they are agentic LLM systems that plan actions, retain long-term memory, and delegate tasks. So sort of addressing our three issues. Maybe you've used some of them. You probably have. So Replit, Microsoft Copilot is constantly, at least on my computer, asking to do things for me. Manus sort of brands itself as a general AI agent that can do anything on a computer. Claude Code is ever increasing in popularity and sort of runs in the command line and therefore can basically do anything, but is sort of branded as a coding thing. I also just saw Claude came out with like a co-work, which is basically Claude Code rebranded to do more than coding, even though Claude Code already can. GitHub Copilot, which I use all the time, which can do things like look at code bases, read code, write code, open pull requests, all these sorts of things. And then where this term is from is LangChain. So LangChain is like a open source agentic framework, and they have this thing called deep agents, which is what this sort of presentation idea is inspired by. And it sort of breaks down how all of these things actually work. And there's this other section, which I'll call deep research agents. And they are, they're not interacting with interacting with your computer and able to do all sorts of stuff. They're just for answering hard questions. And so Google, Gemini, OpenAI, Claude, they all have some sort of research agent that is meant to sort of go online and sort of spend more time answering your question and actually find sources, etc. In our inbox, we can say that deep agents can handle complex tasks with multiple dependent tasks, manage entire email threads, sort of with long running conversations. And we'll look at how it's able to do all this right after. Coordinate different task systems, resolve context from vague requests. So it should be able to do basically anything a human can. And so deep agents are able to autonomously handle complex and long-running tasks. And I think it's important to emphasize that so on their own, these tasks could be done by agentic LLMs on a small scale, but deep agents add like a lot of like reliability to this process, and we'll look at how. So we'll sort of go over the four core components of what makes up a deep agent. And so the first one is planning. And so this is to help the agent stay on track, using like a planning tool to steer the agent. So for these general agents, it's likely like a to-do list. So it makes a to-do list. It consults the to-do list at every step to make sure it's actually done what it was supposed to at the start. And then for the research agents, they will write a research plan, sort of the same thing, and then make sure to follow the research plan. Another core component is the file system. So this is basically to just try to fix the problem of the context window. So the file system, we can store the plan, we can store necessary context, and one of the most important things is storing token-heavy tool observations. And that is to say, like, if you have some agent that goes onto the web, searches for something, and brings the results back, you don't just want to dump the results in the context window. You don't want to like explode the context window. And so it would be better to store the results in the file system, make a small summary of the results, and give that to your agent, because then the agent can, if it decides it wants to know more, it can look into the file system, so it can look into the saved results without exploding the context window. The third of the four is sub-agents. So when I was talking about how agents are, sometimes the scope can be too big, like there's too many things to do, too many different things to do. A very common thing is to have sort of an orchestration agent and then specialist sub-agents to isolate context. So we basically have this idea of a different like workers. So maybe for our email example, we have an orchestration agent and then a agent that looks at documents, an agent that schedules stuff and looks at the calendar, something like that. And then finally, we have our ever important system prompt, which, so we still need to have a fine-tuned, thought-out set of system prompts to tell the LLMs how to act. And I would say that it's especially important for the orchestration agent because you want to tell the orchestration agent things like always make a plan to start, like delegate to sub-agents when reasonable, ask before sending emails with documents, those sorts of things. And now we can look at how those components are organized in sort of an architecture way. So we have the system prompt that's set up beforehand and said to the fed into the agent. We have our planning tool, which is updated and consulted throughout. We have our specialist sub-agents, which are delegated to, and then the orchestration agent. Sorry, my headset cut off. Can you hear me, Stephen? My headset.
Yeah, no, I can still hear you.
Okay, good. My headset shut itself off because I have no audio. Okay, and so we also have our file system, which is being used to write and read to and from. Okay, and now we can flip our last one over, which is deep agents are agentic systems that are able to solve complex problems autonomously. Now we can go through a worked example to sort of cement everything that I have said. So here's the scenario. It's you, 4:45 on a Friday, and you're not looking to do any more work, frankly. You're done. A new email hits your inbox. Maybe it's something from IT. Maybe it's wishing you a good weekend. Hi, can you send over the reference documents with brief summaries from last week's project meeting? So you definitely don't want to do this. You definitely don't want to stay later. So maybe your email agent can help. First, we'll look at sort of what makes this problem hard for an agent. So again, the ask was, can you send over the reference documents from last week's project meeting? So the first thing that makes it hard is figuring out the context. What project meeting, what documents? Where are those documents? How can you be sure they're the right documents? And how can you be sure that you can send those documents to this person? How to efficiently summarize the documents, like what sort of summary is needed? And what if some of the documents are very long? So all sorts of problems that require planning, multi-step reasoning, long-term memory, and multiple agents, which sounds like a good use for a deep agent. And so we will sort of go through how each of these components works in this situation, starting with the system prompt. So first of all, this is my most text-heavy slide, and I apologize in advance. So the system prompt can also be thought of context engineering. So we need to tell our agent how to act in various situations, how to communicate, etc. The first one is how the agent will plan and then go through that plan and reason. So we can say, create a plan before acting. Once a step is complete, reconsult the plan, and don't proceed until sending an email until all required steps are complete. We'll also want to tell our agent how to handle documents and context to sort of protect our context window. So we'll say, like one of the first steps is to create a context summary. And so it will sort of figure out the context and then put that in a summary so that the other sub-agents have access to that and it doesn't need to be figured out again. Avoid including outdated or duplicate documents, only include verified and relevant ones. And then when going through documents, save them one by one in system memory. So don't try to do everything at once. We also want to tell our agent how to act responsibly and when the human will be consulted. So things like always ask for approval before sending emails or sending emails with attachments. If something is missing or unclear or feels risky, wait for approval. And if uncertain, pause and ask for approval or clarification rather than guessing. And finally, we want to tell our agent how to communicate. So how the agent will write emails or maybe even write to the user. So polite, professional, well-structured, all these sorts of things that it's good to tell LLMs how to communicate. Keep in mind the two that are in bold, create a plan and create a context summary, as they will come back into our example very soon. We can now look at the specialist sub-agents. So of course we have our orchestration agent. And then for this example, we'll have a context agent, a document agent, and a summarization agent. And a real system might even have more. But for this one, we'll just look at these ones and their responsibilities. So the orchestration agent makes a plan, decides the next actions by consulting the plan throughout the problem, and then decides which sub-agent to go to, and then validates their output. And this is sort of not a for sure, but sometimes you would want your orchestration agent to have the final output, so to write the email because it has full view of the context. But maybe also you want a specialist email writing sub-agent. That's not a guarantee. For the context retrieval sub-agent, it is sort of in charge of determining missing context. So what documents, what project, and then providing a structured context summary. Our document lookup and retrieval agent is therefore finding the documents from an internal drive or a wiki and then verifying their correct, authorized for sharing. And then the summarization agent just summarizes documents. So that is our agents. And so we've set up our system prompt, we've set up our specialist agents, and we're ready to start the problem. So our orchestration agent sees the email and knows you want it to do it for it and starts making a plan. So the first part is create a context summary to identify which project and documents the email refers to, retrieve the files from a shared drive or wiki, check their most recent, summarize the key points, draft a reply email, and then ask a user to approve before sending the email because, of course, we've told it that don't send an email with attachments without asking. And so we can see that here. We've consulted, or we've made a plan, and so we can store that in our file system memory. We'll sort of keep track of what's in our memory throughout this problem, so we can say the plan is in there. And we can look at the plan, and the first step for the plan is create a context summary to identify which project and documents the email refers to. So this would be a great use of our context retrieval sub-agent, who will look at who the email is from, maybe if it's in an email thread, other emails from that person, maybe look at like AI transcription, or if there's like some meeting notes somewhere, something to help it figure out which documents and which project, and then it will make a context summary so that can be shared with other sub-agents throughout the rest of the problem. And then that is also stored in our file system. And so we can add the context summary. And then from here, I'll just sort of stay on this page instead of jumping back and forth. And it should be clear sort of how the memory is used in context with the agents and the plan. So our next step is to retrieve files from a shared drive. We'll use our document lookup and retrieval agent. It will find the 4 documents that were sort of identified in the context summary. Then we're checking their most recent, which is also the job for the document lookup and retrieval agent. It verifies their recent, summarize the key points. We'll, of course, use our summarization sub-agent, make a summary for each. And then it's time already to draft a reply email attaching the documents. And so the orchestration agent will have all of these things. So it has the context, it has the documents, and it has summaries for each document. And so it can write an email that might look something like this, with the documents attached at the bottom. And so maybe the summaries are too long that the summarization sub-agent made, but the orchestration agent is, of course, allowed to summarize even further because obviously we want these to be sort of short. And so we've drafted the email, and now the final step is to ask for user approval. And so that sort of wraps up this example. I hope it was helpful. And now we can sort of wrap up by talking about the current, the future, and some upskilling and resources. So to me, and if people have comments, I'd be interested. Sort of the biggest thing that everything is working towards in Agentic AI is making all the prototypes and betas that are floating around into useful, which I think some are, and reliable, which is much more of a question to me when I've been using agents. Make sure they're useful and reliable in production, and to make them all work together, of course. Something that is both challenging and an opportunity is how many choices there are. So there's sort of an endless choice of like ecosystems and models and frameworks. And so making them all work together can be hard, but also lots of choices good. Another thing making these more useful, I would say, is this idea of swarms of agents. So it's like having many deep agents that can work together side by side. In like a business example, not that I know very much about business, but you could have like a sales forecasting agent and a customer service agent, and maybe they sort of work together in some way. And I think this is still very up and coming. End-to-end execution. This is a question of how much agency do the agents have? So how much can they just use your computer like you could? Like, can they do anything they want? And then the sort of question about how much autonomous decision making versus how much human is left in the loop. And I think that is very much up to the user of how comfortable they are with letting an agent just sort of like run free. And then the adaptation maturation of MCP, or Model Context Protocol. And this is sort of a protocol standard that lets agents communicate with other agents and tools through a shared structured language. And so I think all of these things will sort of build up and promote the useful and reliable agents in production. To finish off, we'll look at some sort of upskilling avenues and resources. So LangChain Academy, this is basically how I know most of what I know. And it's hands-on building with LangChain and LangGraph, which are their two libraries about agentic LLM workflows and deep agents and deep research agents. There's also Deep Learning AI, which is many free short courses on a huge range of topics and tools, more and more agentic, I would say. And they have a lot of like people from different companies come in and give these short courses, which are like, but they're still good. Like it's not just a full like a sales job. They still are teaching you how to use the tool the company made, which is useful. Hugging Face Learn. Most machine learning or AI engineers that I know use Hugging Face with some frequency, and so they have good resources on building with LLMs, agents, MCP, etc. Anthropic Academy. So Anthropic has great courses at MCP, AI fluency, and how to use Claude. And then, although I don't know what IBM does anymore, they do make really good educational material. And so they have a 2025 guide to AI agents, and it covers architecture, protocol, frameworks, MCP, RAG, all of these things, and much more clearly and in more detail than I have today. And finally, there's this weblog from Sam Willison that I like quite a bit, and it isn't so much a resource as just a place to go and learn what's trendy and what's new, and it has news, opinions, sort of first looks at things, think pieces, etc. And yeah, so that's all for me, and now we can move on to the Q&A, and I'll let Stephen come back in.
Right. Thanks very much, James. That was really interesting, and I think the way you laid out your presentation made it kind of easy to understand especially for me, somebody who's not got a technical background, accessible and understandable. So thank you. We've had quite a lot of questions coming in, so I'll try and get through as many of them as we can. The first one here, pardon me, is from Rory, who's asked, so he said, you've used kind of inboxes as an example of how the tech has progressed over the past 7 years and also an example of how it would work kind of in practice now. But the question is, which other real world applications or real world workflows do you think that are likely to be fully automated by deep agents kind of over the next few years?
Okay, fully automated. I think the sort of the first one that jumps to mind is customer service. I think customer service is already sort of on the way to being heavily automated. Um, Maybe it's like personal to me, but it won't be fully automated, but something that is already using AI a ton is coding, right? Like everyone who's coding now is using some sort of LLM, and I think it will be sort of keep, um, I think that will keep going until things are highly automated, but maybe not fully. But I think it will appear in lots and lots of places and lean more towards fully automated for lots and lots of places.
And it's the kind of the benefits of agentic AI are kind of all over the news around the kind of the benefits to productivity and kind of making the change in the way we work. But so I used to work at a company that was an event management company, and there was a lot of admin involved in that work, and there was a lots of emails going by. When do you think this sort of technology is going to be like easily accessible to the kind of normal businesses who might not necessarily be tech businesses, but would benefit from this? Do you think there's like when do you think this sort of stuff will become
I th
more
Yeah,
accessible?
I think in terms of things like email, it is it is just going to be like baked into every email inbox. So if you have like a Gmail inbox or Outlook, it'll just be like baked into it. And I mean, I wouldn't like trust it to do a good job right now, but maybe in 2 years, I would say it'll probably, my guess is based on the progress I've seen in the last 2 years, in 2 years more, it'll be probably much more reliable and more trustworthy to do things like answer emails.
Brilliant, thanks very much. So, yeah, so we've got a lot of questions here, so we'll get through those. So, Rory's asking, have you seen any common mistakes that teams make when they first try to build an agentic system? What are some of the pitfalls that you might try to avoid?
Yeah, well, certainly I have made some mistakes while building agentic systems. Um, One is, yeah, trying to have it do too much at once, like trying to start from the top down. So instead of making it do like simple things at the beginning and verifying that and moving upwards, trying to make it do everything at once. Um, and then it becomes very hard to validate or figure out why it's failing, I would say, because there are so many parts happening at one time. Um, yeah, that's an interesting question.
So kind of start small and build up from
Yeah,
there.
I would say generally that's just a good thing to do.
And then, so we've got an anonymous question here related to page 14 of your presentation.
Yeah.
I think you'd mentioned that there was a technical limit on how many tokens an agent could use or could access. I think it was in relation to the context window, I think you called it.
Yeah.
The
So
person's asking, is there a technical limit to how many tokens can be used, or is it a case of spending more money on it to get more tokens?
so the limit is essentially how many tokens you can load onto a GPU at one time. So and how many GPUs you can set up in parallel together. So because basically the entire context window has to be loaded, so you have to load 100,000 words to predict the next one, like reliably. That's just how they work. So there is limits. They are like constantly context windows are being expanded and expanded. So it sort of seems like there's not a limit anymore. But there's also been a lot of research that even with huge context windows, it still isn't all useful. Like just making a bigger context window is not helping an LLM see see more and like using it in a reliable way. So there is some like functional limitation with the LLM, like how the architecture is, that is outside of just putting more GPUs next to each other. Um, and so people have sort of learned that we can't just keep making context windows bigger and expect like more and more like performance, like more reliability. Um,
Is that where the you mentioned the kind of having the files that the agent can look through
Y-
to kind of get the
Yeah,
information. Is that where that comes in?
yeah, I would say sort of exactly that. Should have named him a little bit. Yeah. So sort of the file system, that's exactly where that comes in, is essentially offloading things onto the context window. So like one thing is like the plan. So the plan isn't written to the file system, like made and written to the file system. The whole point of the plan is because if you make a plan at the beginning and then just go on the plan, the plan keeps getting pushed further and further forward in the context window, and then it will inevitably forget what the plan was.
Right.
And so if you have a plan stored and you have this and the plan, even if in the plan it says like reconsult the plan, it will know to go do the thing and come back to the plan. And the plan is in memory, right? It's in this file system, so it's static. Like it can't be forgotten. And so that's sort of, yeah, it just can sort of read over and over and over as to not forget it, essentially, to keep putting it in the most recent position in the context window.
Yeah, Lawrence is in the chat has said continual curation of the context is key to overcoming memory, not unlike how humans curate their materials.
It is true.
Okay, cool. Thanks for it. So then, yeah, I'll try and get through. We've got a question from Terry here who's asking, would it be prudent to have a business version which can only use authorized content to search through to avoid leaks and hallucinations?
Yeah, so I think that would be a big part of the sub agent is only giving, if that's what the question is, only giving the sub agent, like this document sub agent, access to like the corporate like like drive essentially, and sort of making it in a box. So not actually in this context, you don't need the LM to go on the internet and search stuff. So if you're really worried about that, you don't have to allow it to at all. Like only allow it to look in internal things. Yeah, I think that would be a good idea.
Yeah, I think Jane has asked a kind of related question. You mentioned some of the limitations of the agents regarding the context window, but I guess in addition to what you just said there, are there any other safeguards that you think would be essential, especially if you're letting your agent interact with an external system or data that is kind of potentially sensitive?
Uh, yeah, so what we've just mentioned, only allowing access to things this agent needs access to. Um, there are lots of other things like being able, like making it like cite sources. Like, if it's going to make a claim, it has to cite a source from somewhere. That's good for not allowing hallucination. Um, but yeah, that's a big problem. If you're going to let agents do whatever they want, they're going to do whatever they want. So that is sort of the pro and con.
Setting clear rules and
Yeah,
restrictions on what you
yeah,
can
and that's
actually
a lot
do.
of that comes in the system prompt. Yeah, and but also like the system prompt. I mean, it is they're trained to follow the system prompt, but also it is it is not unheard of for them to go outside of the system prompt if they think something is better, and then you have a problem on your hands that needs to be checked in like a more technical way.
Okay, great, thanks. And then, so Madeline's asked on page 40, you discussed the human in the loop aspect. What skills do you think are needed for the humans in the loop, and particularly for non-data and digital folk who maybe not quite have the same technical background?
Yeah, so I think that how much the agent, if the agent is sort of supposed to be helping you or adjacent to what you're doing, then you will already know how to interact with it. Um, like in the example, like if you have the context of what documents and if they should be shared with this person, etc., then like you don't there's no specialized or technical training to answer like yes, this email is okay. And so I think there's a lot of like philosophical questions on how to keep the human in the loop, and there's some technical questions about people who make agents about like yeah, how to keep the human in the loop, but actually interacting with them. I mean, to me, it should be as easy as like you know better than the agent does. The agent might be doing the work, but you know better still. And so it should be as easy as saying like yes or no, or do this or do that. One of my colleagues says still, and I think he's right, thinks of agents as like a new intern who can do things but doesn't really know why or what they're doing. And I think that is still very much true.
I think that's what Lawrence has said in the chat as well there. They've considered the human loop as the managerial oversight,
Yeah.
uh, looking over the work that the kind of the new interns have done. And then um, on Terry's asked on page 26 of your slides around validation, could you have a matrix to highlight a range of a range of scores which would need and would not need to be redirected to a human or another bot with more detailed info?
Sorry, which page was this? Oh, I see the
Page
question.
26,
Uh,
Terry Francis. Could you have a matrix to highlight a range of scores which would need and would not need to be redirected to a human or another bot?
um, Gosh, I don't think I understand the question entirely.
Terry, if you're still on the call, maybe if you want to give us a bit more context for your question, maybe we can come back to that one. Um, but then we can maybe move on to so somebody's asking just more around the kind of skills side of things. But this person is currently studying data engineering. How likely do you think AI agents will? How likely do you think it is that AI agents will potentially replace entry level and mid level jobs at some point in the future?
Well, not to be sort of I'm not very confident that it will, to be honest. I think it's possible that it would replace, especially for things like data engineering and software, like um I can't see a path where they get so good that they can do these things like really reliably to the point that they don't need oversight. At least not soon. But I would say that it's so hard to know. It's
For someone who's looking to get into agentic AI, what skills do you think are most important to be focusing on? Should they be looking at kind of machine learning knowledge, software engineering, or is there something else that people should kind of focus their time on if it's something they're interested in?
well, yeah, I come from quite a like I come from like a software engineering background. So I do think, and almost, I mean, a lot of it is happening like in Python. So I would think you couldn't get away with not having some basic amount of Python. Um, but yeah, the skills now are very different, and it's a lot about like orchestration and architecture, and you don't need to, you know, knowing how to code is definitely useful, especially when things go wrong. But there's now with all of the agentic tools to use as well, like agents to help you build agents, like using GitHub Copilot or Claude Code. Um, I would say a lot of it is about um, being good at using those tools and having some sort of uh, architecture, being able to do like the architecture or think about the architecture. Um, but I would be surprised if you could get away with no coding knowledge anymore. At least that's my hope because I don't want to be replaced either. So
Do you think it's specifically Python, or do you think it's more about focusing on the kind of fundamentals and the theory of this kind of how the languages work?
yeah, I think it would obviously it's just good to know one, just to know sort of anything. But a lot of the work is being done in Python. So if I had to tell someone to pick one, if someone wanted to become an AI engineer, I would tell them to pick Python.
Okay.
But I would also say you no longer need to really like drill down on learning, like every bit of syntax and all these things to be sort of an engineer now because there's so much that is being done for you.
Brilliant. Thanks very much. So we've run out of time, unfortunately, but it's been a really interesting session. So thanks very much again for taking the time to
Yeah,
prepare the
thank you.
presentation and deliver it in a way that was kind of accessible and understandable. There have been a lot of comments of people saying thank you. So I think it's gone down well. If anybody is keen to get in touch, maybe they've got questions, what's the best way to get in touch? Would it be through LinkedIn or?
Yeah, it can be on LinkedIn or yeah, I think I'll probably make or have someone else from Detective make like a post on the Data Lab community like blog, and we'll share the slides and the discussion can continue there.
Brilliant, yeah. So we'll make sure we send around the slides, and we've recorded the session today as well. So once we get the recording back and we get it up on YouTube, we'll send around a link to everybody who's registered. So keep an eye on your inbox, and we'll send that out to you. Thanks again, James, for joining us.
Yeah, thank you.
And just as a final reminder for everybody who's here, if you are interested in the data visualization competition, it closes at midnight on Friday this week. So if you've got until midnight to submit your projects. So thanks very much, everybody, and we'll see you for the next webinar. Actually, we've got another webinar coming up tomorrow afternoon. It's a public sector webinar, so if you're interested in joining, it's around the Digital Skills Academy within the Scottish public sector. So maybe see some of you there as well. Thanks again, and see you next time.